Going to talk a little bit about the GPS8 performance mode, what's the theory behind it, and the design criteria for it. Then we'll do a small demonstration of how it runs. But first, let's take a look what is performance mode. It is actually a software option for GPS8, and it can be added to any device, even the old ones. It is a feature to enable driver and vehicle performance measurement between specific speeds or distances, and even has a FIA starting sequence built into that. We'll see that as well during the demonstration. It is compatible with any CAN equipped device, or you can load the data into the GPS8 USB memory stick. Now let's look at the design criteria. The system had to be easy to use without any buttons. Then there had to be two operational modes, one from stationary standstill, and the other one is between speeds, let's say 60 to 120, for example. And then maybe the most important feature was that the driver can see the results immediately without needing to come to the pits. And then also that the data is in the same place with all the other engine data. Now let's take a look how it works in real life. The requirement was that there's no buttons, so the system is armed simply by stopping the vehicle and waiting for the launch sequence to start. And then when the lights go off, then you go. And that's where the reaction time is calculated. So from the moment when the lights go off to a point when the vehicle starts moving, that's your reaction time. Also the false starts are indicated with the negative time. Then the run will continue until you have reached the max speed minus 10 kilometers per hour, and that's when the results will be visible and will be sent to the CAN bus, and the driver can see them. These are now the available results, both in metric and US units, so kilometers per hour and miles per hour. This depends how the device is set up. Now let's take a look how the system actually works in real life. This is actually a simulated run using the real data. We have a capability to generate runs from any MOTEC data. So this is real data, but I'm playing it back here in the lab. So let's go. Let's take a look now how the system actually works. So over here there is a MOTEC C125 color display. It is being used to show the starting lights and some other parameters like speeds, etc. Then we have GPS8 display, which shows the logging status, speed, coolant temperature, satellites, etc. So let's see how the sequence works. So now we started. We have the lights 1, 2, 3, 4, 5, random time, and now we are running. Reaction time was 1.186 seconds, and over here we have the speed, for example, and we are logging the data. So this test runs until we have reached the max speed minus 10 kilometers per hour. So around 110 kilometers per hour we should see the results. The max speed in this run is 120. So at 110 we should see the results. So now we are slowing down. So soon we should get the results. Here they are, 5.7 seconds, 8.6, etc. Also the data from the GEMS tool, what we logged into the GPS8. Let's see what the data looks like now. This is the GEMS Data Analysis Pro. That's the tool we're using here today. Here's the data file. We'll import the CSV. CSV is the format we use in GPS8. So here we have the run, the complete run. Here we have the start sequence, which is effectively the starting light, time, start reaction time, run distance, GPS speed, and here we have the GPS track. So here is the light number 1 is on, second light, third, fourth, fifth, and the fifth light has the random period. And 6 is the point when the lights go off, and that's when the start reaction time calculation starts. So time between this and this point where the car starts moving here is 1 km/h. So if you remember, the result was 1.186 seconds. So that's where we are. So here the run continues. Here's the first performance measurement. 30 km/h, 3.4 seconds. Here's the second speed, 8.9 seconds, 60, and then 100. And here we have the distances. So 25, 50, 100, 125, etc. So let's mark the starting point here where we left and see how accurate the measurement is. So here we have the starting point. Let's mark it. Let's put start here. Then we can take the distance of 100 meters. 100.3, close enough. Then we can take 200 meters. 200.5. We take the markers we set. And now we are opening the track we did. Welcome to sunny Spain. So here's the starting point where we left off. And we can, with this tool, we can measure the actual measurement. So here's the starting point about here. Here is the 100.3 meters, so 99.93 meters as you saw there. And here we have, about here is the pin, 200.79, 200.5 meters. So pretty accurate result. So if we compare that to the GEMS measurement, which is calculated from the speed, if we take the 100 meters here, it's 104.9, 105 meters calculated from the speed. Here we have the 200.5, it's 205.9 in the GEMS using the speed. We don't actually calculate the distance from the speed, we calculate it from the GPS coordinates. So that's why it's more accurate. That's it for today. I hope you liked the video, and please subscribe to our YouTube channel and check our webpage. There's a lot of information on our GPS product. So next time we are talking about most likely about GPS pulse feature what we have in GPS8. So till then, bye.